Hello everyone, hope you are doing well. Welcome to the online platform Civil Techno Bricks. Guys, here we will tune for the instantaneous decoding of the conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today, we will go through the core concepts of geological subsurface exploration in view of civil engineering and its applications. In today's construction activities, we will study the geological subsurface exploration in the civil engineering domain or perspective. Before constructing any engineering structure like dams, bridges, buildings, tunnels, highways, we are the engineers must understand the continuous impact and the conditions beneath the ground surface. Subsurface exploration helps us to identify soil layers, rock formations, groundwater conditions, and geological discontinuities below to the subsurface. This information is extremely important because underground conditions directly affect foundation, its performance, and its structural safety. Therefore, geological subsurface investigation, which is the one of the most important stage in civil engineering planning and design point of view. The geological subsoil or subsurface exploration depends on the three conditions. What are they? Geological structure, engineering hazard, design solution. The folded rock structure, which gives or which explains the shape, size, and physical conditions of existing rock with reference to its orientation. That geological structures may get damaged or may get crackened with reference to the tectonic plates vibrations or any subsurface activities just like earthquakes or just like landslides or any collapse, where we have to identify the unstable joints and sliding planes before that activity. Geological structures helps us to study for the structural analysis point of view in the civil engineering domain based on the survey data. So with reference to that geological formations, there are n number of failures just like shear failure, then joints, then faults, n number of slip or n number of activities which are man-made or natural which affect the existing or pre-existing rocks. So we are the engineers, we have to study the geological structure first, and at the same time we have to focus towards the engineering hazards which will be in coming future will occur due to that construction activity based on some geotechnical interventions, based on some geological characteristics, some soil explorations. We have to define or we have to assign the safety protocols, or we have to work for that safety protocols so that our construction activity must be in efficient manner. So at the end, which gives the design solution for the construction point of view. Here the tunneling example is taken. By using the tunnel boring machine, we are extracting the data or muck from that tunnel, where we use the reinforced steel design for creating the outer covering. So objective behind that architecture to prevent the risk is define the architecture of rocks from flat tabular masses to the complex folds or the characteristics of the geology. Why we have to do this? Because we have to maintain or achieve the economic efficiency, where mitigation of unforced or unforeseen ground conditions that cause project delays or project failures. So what are the stakes? It is the futile to study structure without knowledge of stratigraphy. Means we have to be aware about the strata, stratigraphy, orientation of rocks, their types, their characteristics. So reconnaissance, that is the bird's eye view. What is meant by reconnaissance? Reconnaissance is nothing but the one of the survey, or we can say that the preliminary survey, which is most important for to study or to get the orientation of the layout of topography. With reference to the reconnaissance survey, we get the rapid assessment of the terrain or topography based on some area, just like for 50 to 200 square miles. For that reconnaissance survey, We can use nowadays GPS, GIS or any IRNSS tools for the surveying, just like aerial photogrammetry or satellite imagery. With reference to that, we check the performance of any structure dependent on that gravity or the rocky surface, which provide the strength and stability for supporting ground. For any dam and tunnel point of view, geological conditions become even more critical because underground discontinuities may create seepage and instability. So what are the tools used for reconnaissance? Vertical aerial photography, which reveals unsuspected structural features invisible from the ground. All the materials which are associated with the ground surface with reference to its slope gradient, they are all studied by using that aerial photogrammetry. Remote sensing, where we use the rays that are infrared rays or some radar for surface texture or moisture condition point of view. With reference to topography, we can check the drainage patterns, that is valley lines, ridge lines, so that the impact of that rainfall or the impact of that valleys and its necessity for the road construction or tunnel construction point of view. Means the reconnaissance survey is nothing but the bird's eye view. We can check the topography with reference to the bird's eye by the use of aerial photogrammetry tool or remote sensing tool based on some contours, based on some geological subsurface exploration. The charting the surface, that is mapping, means we have to prepare a chart. Why we following the chart? Because chart is a tabulated format or descriptive format where the IDs are assigned to the respective phenomenon. Means that phenomena which gives us the exact explanation of that surface or of that layer or of that zone. Means in planning and zoning point of view of the topographical, or we can say the digital elevation model or digital surface model, so we have to divide the surface with reference to that charts. So that chart may with reference to some angle of deep, with reference to some angle of creep, with reference to some colors, with reference to some texture, with reference to some alignments or the data enclosed in it. So what are the legends or keys used? Deep, which shows the slope direction at that point by taken the GPS. Strike, which gives the direction, and 60, which is the angle of deep. So the foundation base required for the every construction activity must useful for the successful fieldwork consist of accumulation of significant facts which are beneath to the surface or on the surface. We have to record the data just like the characteristics of lithology or surface or topography. Then geological components like strike and deep or bedding planes, joints, folds and faults and its classification and orientations. So charting the surface, or we can say that the mapping the surface by the method of accurate location via GPS or topographic base activity. For process point of view, mapping is done with reference to that interpretation of working multiple hypotheses. Means we have to follow n number of methods or n number of interpretation or n number of GPS locations for a single topography for the cross check point of view, so that we get efficient data and we have efficient planning of map which required. Non-invasive diagnostics are used or explained with reference to that geophysical methods. What is meant by geophysical methods? So geophysical methods are used to study the activity beneath to the surface based on some non-destructive techniques. We have to check the material inside to the earth crust, but we can't use any destructive technique, that is excavation or any drilling methods. So in geophysical methods, seismic refraction in the first case, then magnetic anomalies in the second case, and gravimetric survey in the third case. Seismic refraction, where a single vehicle is there, that vehicle which is playing the role of rover with reference to GPS and GIS connection, and at the same time we are the users who assigning the query based on that vehicle which is moving on the surface of the earth. When that vehicle is moving through the surface of the earth, that vehicle capturing the data beneath to that vehicle with reference to some rays which are emitting inside the soil layers or water layers or bedrocks or rock layers. And at the same time, that whole incident rays are reflected from that each and every layers by detecting the characteristics, index properties and requirements of the queries to the user. The magnetic anomalies, where we are using the infrared rays, or we can say that the color based ray for checking the intensity of anomaly, that is low anomaly or high anomaly. By using that aerial photogrammetry point of view, we are considering the whole terrain based on some contours, and that contours are most important for checking the distance in between the two contour, which is the most important phenomenon required for that magnetic anomalies. In high anomaly, the contours are too much less space in between them. That's why their red color and dense red color is noted in high anomaly. At the same time, blue color is there for low anomaly with reference to the space in between the contours. Where gravimetric survey, which is the actual survey done by surveyor on the site with reference to some advanced total station or any DGPS, where that whole instrument is playing the role of rover and we are the users. We assign the input by the controller to that. At the same time, we emitting the rays below to that earth surface so that we can monitor the materials which are available beneath to that earth surface by using that gravimetric survey under that soil or ground layers. So what is the role of non-destructive diagnostics or non-invasive diagnostics? That is the X-ray for structural geology, where exposures are rare. Why we are doing this? To use determining the depth to bedrock for dam foundations, for tunnels, for highway embankments or for railway embankments. So what are the limitations for that? Detects physical contrast, non-specific rock types. Means where n number of fluctuations in the rock layers or soil layers, they also detect the physical contrast in between them. Scratching the surface is nothing but the trial pits. The trial pits are shallow excavations made to inspect subsurface soil conditions directly. Trenches are longer excavations used to expose geological structures like faults, joints, or buried layers as per the diagram. These trial pits or trenches method are allows engineers to collect soil and rock samples for laboratory testing also. They are most economical and highly useful for shallow foundation investigations and highway construction projects to satisfy the goal of verifying contacts observed by topsoil. So what are the applications? Small faults may be observed in artificial exposures by using that trenches cutting, so that we get the fault line, textures, patterns of rock layers and everything. Probing the deep, that is boreholes, means we are providing the drilling methods or boring with reference to that artificial equipments, that is borehole A, where that borehole is exactly downward from that vehicle into the soil, but the whole soil is cover of first soil layer, then some of the rock layers and again anticline rock orientation. Why we are checking that deep? By using the ore bore wells, which we require when exposures are rare or structures is complex, means we have to study the complex layers beneath to the earth surface, so that we are preferring the borehole technique. Boreholes provide detailed information regarding underground strata, groundwater conditions and rock quality. When we goes deeper in for the investigation, engineers use drilling techniques to create boreholes. Different drilling methods such as auger boring, percussion drilling, and rotary drilling are selected depending on the query or the ground conditions. The collected borehole data are extremely important for designing the deep foundations for the dams and tunnels. With reference to that, beds which are available of soil or rocks, the key beds we are marked for our sake of interest to match the data across multiple boreholes and compare the data from that multiple boreholes. So what will be the output? Reconstructs the 3D model of the subsurface from vertical data points. Means we are plotting the vertical data points on the surface of the earth. With reference to that vertical data points, we are reconstructing or comparing the 3D model below to that earth surface, and it will give us the output for sake of our project. The mechanics of extraction, why we are doing the extraction procedure or extracting the data, that is the destructive versus preservative. So preservative means we have to collect the sample and preserve it, and destructive means we have to dis- destruct the sample or destruct the existing rocky layers. That is percussion drilling or chipping method, where tungsten carbide buttons or drilling bits are used to drill the existing rocky layer and make them rock in the fragments. So that chips are good for designing the ID or assigning the ID or assigning the nomenclature. That destroyed structure make useful for the sample point of view also. For the rotary coring, diamond impregnated drill bit, which is one of the type of drill bit is used for rotary coring. With reference to that, we can core the sample from any roadway or any rock strata to preserve it, to for study the bedding planes, then structural joints, deep angle strikes, and many more geological components. So core drilling, a specialized method used to obtain cylindrical rock samples from deep borehole. These rock cores provide direct evidence regarding lithological characteristics, weathering actions, fractures, and joint conditions beneath the earth's surface. Engineers must evaluate rock quality designation to determine the integrity of rock masses by using that rotary coring samples or by the percussion drilling method chips as per their nomenclature. The core analysis plays an important role in tunnel design, dam foundations, and underground excavation projects. So the rotary coring is essential for structural geology. It is the only way to map or measure deep and joint spacing with reference to the soil layers or rock layers. Reading the cylinder or the core sample, we core out the cylinder from that rocky layer by using that rotary drilling to visualize the geological components like dip, where angle between the core axis and bedding reveals the dip amount, which gives the clues that veins, fractures, and polished surfaces, just like silicon sites, indicating the faults for that sample. So, soil and rock samples are collected from boreholes and excavation pits for laboratory testing. Disturbed samples are mainly used for classification and index property determination. Undisturbed samples maintain natural structure and are required for strength and compressibility test. Accurate sampling procedures are extremely important because poor quality samples may lead to incorrect engineering decisions based on that core axis, bedding planes, apparent deep, silicon sites. Why we are studying that cylinders or samples? Because we have some limitations, like it gives amount of deep but not the direction of strike without orientation tools. With reference to that core drilling samples collected, we have to bifurcate or list out that samples based on some characteristics. So we have to maintain some descriptive vector data, that is a tabulated format core log. The core log table explains that the depth, lithological characteristics, that is symbol, some description for that symbol, and fracture count. Means the geological components characteristics are listed on the title of the column, and with reference to that we are taking the readings, that is depth in meters, lithological symbol with reference to its texture or pattern, description just like the type of rock, then color and its nearby rocky layers, and followed by the fracture count which is noted. That cataloging, which is most important for the analysis point of view, where the comparison and the analysis which are most important for taking the decision owing towards quantifying quality, that is RQD, which explains that the rock quality designation, the RQD, which is measured in percentage, it is the ratio of sum of the lengths which are greater than 10 centimeter to the actual total run length. So total run length is equal to 100 centimeter as shown for any rocks drill out sample, and with reference to that we are checking the rock quality. So what are the significance, what are the characteristics, or what are the strength and weaknesses, faults, fractures. Likewise, geological characteristics, we can decide the quality of rocks and we have to design it, or we have to assign the nomenclature or designation for that. So what are the significance for that block? High rock quality, low rock quality, that is high rock quality designation greater than 75% and low rock quality designation below to that 25%. So above 75%, that rock masses are strong and have less joints, but for low quality or low RQD, the rocks are weak, highly fractured, and heavy support needed for that. So what is the context, or we can say that the application point of view? We are used to estimate tunnel support and foundation bearing capacity. Means the RQD plays the role by for the civil engineers to decide the policy or the design phenomenon for the tunneling and its foundation, or highway alignments, embankments for railway and roadways. Based on that geophysical exploration methods, or in seismic refraction method, or in electrical sensitivity method, we are taking the data or collecting the data by using non-destructive techniques. So we are unliking the drilling. Geophysical methods investigate underground conditions indirectly using physical properties of earth materials, and that whole earth materials are checked by using that rock quality designation. Sometimes geophysical surveys are also useful for that purpose, which are most economical for covering large project areas. Seismic waves are also generated on at the ground surface, and their travel times are recorded with reference to wave velocity, and that wave velocity also detects some quality of rock, and we can also design that qualities based on some listing out core log, and designation will be assigned with reference that the engineers may take their decision for the strata. Electrical current method or electrical resistivity method also used to check the resistivity of the ground or below the soil layers and rock layers. Different geological materials show the different resistivity values, so that resistivity values also most useful for rock quality designation and its nomenclature findings. Strategic interrogations. Why we do the interrogations? Because we have to know the extra investigated information. So here the 3 point problem, which is most important point, just like the trilateration procedure or triangulation procedure of surveying, we have to design a strategy first, and we have to use that strategy for that interrogation or data collection point of view. So what is the concept behind that? Using three elevation points to mathematically calculate the strike and dip of a planar surface. Means A point, B point and C points, they are equispaced to each other. We have to assign the GPS location, and we have to collect the data by using the GIS on the earth surface first, and after that we are assigning the query to collect the data below to that A point, B point and C point in tabulated format, which is a vector data, that is descriptive data. That data must be on the basis of characteristics of the soils, characteristics of the rocks, index properties of soil and rocks, or their patterns, geological components like fault plane, bedding planes, fractures. Also, we can check the strike, slip, deep angle, strike direction, and everything. So, why we are doing this? Because if we are planning to mark a tunnel alignment, so we must have to know that all activities beneath to that earth surface or beneath to that rocky layers. So spacing depends on structural complexity and depth, which is the drilling must extend below the zone of influence of the project. If the tunnel is influenced by the leakages, then that site is not suitable. But if the whole area is influenced by the rocky layers of igneous rock, then that site must be more suitable for that tunneling. So interrogation based on some strategy based on some planning and based on some implementation point of view, it will be more feasible to civil engineers to take the decision. The uncertainty factor. What is meant by uncertainty? Uncertainty, which is the nothing but a disaster. By using that interpolation risk, geologists must infer structure between data points. Now, if we are taking the A, B, C, D likewise points on the Earth surface, then we are checking n number of characteristics by using some GPS, GIS techniques or radar or remote sensing technique with reference to index properties of soil and rocks and likewise methods. But if we are comparing any two stations at the same time, then there will be some uncertainty factors because there are many undulations just like anticline, syncline, faults, or some symmetrical or unsymmetrical distribution of rock layers or soil layers or any overlapping. These all make some uncertainty in that interpolation zone. So they are explained in that diagram. So sampling which is based on some lost core where 0% recovery is there often indicates that the weakest and most dangerous zones that are fault gauges. What is the rule? Multiple working hypotheses are required. Means we have to perform the trial and error method to collect the data or for the interrogation. Why? Because we have to cross check the collected data previously and we have to update the data currently. Likewise, we can do the multiple working hypothesis for the same to overcome the uncertainty factor. From the data to design. So two images are there. From data to design, that is applications in dams and tunnels. So in with reference to the dam, resist sliding. With reference to the tunnels, we have to avoid unstable or roof collapse risk. So for the dams, beddings orientation detects sliding stability and leakage paths. The dam of the wall must be stable only when to select the site selection for that wall on the stable and hard rocky layers. For the tunnel also, we have to choose the igneous rock probably. So with reference to the tunnels, closely spaced horizontal joints of great concern. Orientation determines support methods, that is bolts versus lining. What are the key takeaways from that subsurface geological explorations? That is define structural geology, which is the architecture of rocks, which shows the descriptive part or the nature of faults and joints. The sequence which is followed for the surveying, that is the preliminary survey from reconnaissance to mapping and drilling based on some remote sensing, GPS, GIS techniques. The mathematical calculations based on some interpolation or trilateration method just like 3-point problems which solve the strike or deep angles and direction using borehole elevations. We collect the samples by using some drilling methods to check the RQD, and that quality designation, rock quality designation, ensures engineers to take the decision for the suitability of foundation for any dam or tunnel, which measures the joint density. Higher rock quality designation is equal to good quality, and the golden rule is that the gap in data often hides the hazard. So always correlate stratigraphy with structure, means we have to construct each and every structure based on the stratigraphical data which is beneath to the earth surface. So subsurface geological exploration, which is most important phenomenon with reference to the construction of structural point of view. Stay tuned guys, happy learning.